So now that we've reviewed our understanding of simplifying numeric fractions, we can extend that out to algebraic fractions. So we know that fractions can be simplified by dividing both the numerator and the denominator by any common factors, and that the fraction is in simplest form if the numerator and denominator do not have any further common factors. So the key first step is about identifying the common factors between the numerator and denominator. And that requires us, when we're dealing with numeric fractions, so for example, if we had 3/6, in our head we're thinking, well, 3 is 3 times 1 and 6 is 3 times 2, so the common factor of 3, we can cancel that down. We can divide top and bottom by 3. Algebraically, that's harder to do in our head. So in order to be able to clearly see the factors, we need to factorise. We want to factorise the numerator, factorise the denominator, so we can then see what's common and what can we cancel down by dividing. Okay, so if we think about this first example, this isn't going to require any factorisation on our part because it's actually already factorised. We can see what the factors of the numerator and the denominator are. So the numerator is 10 times a. The denominator is 30 times a squared, which is a, times b. So then we can look for common factors. So there's clearly a common factor of 10. So let's divide both the numerator by 10 and the denominator by 10. So when we've got all multiplication, dividing 10a by 10 doesn't mean dividing both 10 by 10 and a by 10. Once we've got everything written with multiplication, then we can simply divide really easily. So dividing numerator and denominator by 10 cancels the 10/30ths down to 1/3. We can also see a common factor of a. So if we divide the numerator by a and the denominator by a, we'll lose one of those two a's there. So what we've got left on the numerator is 1, and on the denominator we have 3ab. Again, be careful about the fact that what you're doing is dividing, not subtracting. So when we're cancelling the 10a from the numerator, we don't end up with nothing, because what we've done is we've divided by 10a, and 10a divided by 10a still leaves us with 1 up there. So in simplest form, this fraction is 1 over 3ab. Okay, here's another example. Now, as soon as we've got addition or subtraction happening in the numerator or denominator, we can't cancel anything immediately because we need to first factorise. We need to have everything written as multiplication. We need to see products, which is multiplication. A product of things on the numerator, a product of things on the denominator. Okay, so the first thing we want to do is factorise. And so the common factor here, there's a common factor in the numerator of 2. So we've got 2 times x minus 8. 2 times x minus 4, and the denominator is already factorised. It is 2 times x. So now we can see clearly that the numerator is made up of 2 times x minus 4. There are 2 factors there, and the denominator is made up of 2 times x. There are 2 factors there, and there is a factor in common. It is 2. So we can divide both the top and the bottom by 2, which leaves us with x minus 4 on the numerator and x on the denominator. Now, you may have been very, very tempted way back at the beginning, or you might be very, very tempted right now to go, oh look, there's an x on the numerator and denominator, let's do that. And this is where I want you to think about, what are you doing when you're cancelling? So what you need to be able to do is say, I'm dividing the numerator by x. Now that's not what you've done by crossing out that x there. What you've done there is you've subtracted x from the numerator and you've divided the denominator by x. Okay, so x is not a common factor in that numerator, so there's nothing that we can do. There are no more common factors in both the numerator and denominator, and so we are simplified. X minus 4 over x. You could break that fraction up, but again, it's sort of like thinking about a mixed number. This is perfectly correct as it is, and we should stop at this point, but we could, if we wanted to, say, well, that's going to be the same as x over x minus 4 over x, and then we can simplify the x over x as 1 minus 4 over x. So either of those answers is correct, But again, the first answer is perfectly fine. That's the fraction in simplest form. Taking it those few steps further is sort of equivalent to writing your answer as a mixed number. Okay, let's have a look at another example. So here we've got x squared plus x over x. Now again, there's x's everywhere. It's going to be very, very tempting to just start crossing x's out. Okay, the first thing you must do is be able to identify the factors, and so you must look to factorise the numerator and denominator. The numerator can be factorised by taking out a common factor. X is a common factor there. And then the denominator just has one term, so that's fine as it is. And now we can clearly see that x is indeed a common factor. So dividing both the top and the bottom by x leaves us with x plus 1 on the numerator and just 1 on the denominator. So anything over 1 is just itself, so this is just x plus 1. Okay, here we have a more complex looking thing, but it's still the same aims. We want to look for common factors. In order to see the common factors, we want to factorise numerator and denominator. So the numerator in this case is already factorised. We have factors of x plus 3 and x minus 5. The denominator isn't factorised, but we recognise that we have a difference of 2 squares, x squared minus 3 squared, and so that factorises to x plus 3, x minus 3. And this is where you might need to go back and do some revision of your factorisation skills before you get too far into this, because it really is all about factorisation. And there's an appendix in the algebraic fractions section of your BTG booklet and a link to a video there also with some revision of factorisation that perhaps you might need to go and do some of that before you get too much further into this. Okay, so now that we've got numerator and denominator factorised, we can see all the factors, we can see what's common, and we can see that we could divide both the top and the bottom by x plus 3, and we would just be left with x minus 5 over x minus 3. Now again, it's going to be tempting, oh, I've got an x on the top and the bottom, shall I cross those out? What is it that you're doing? And we cannot divide the numerator by x, it's not common. We also can't divide the denominator by x, so we can't cancel down that x. If you were to cross out those x's there, what you're actually doing is subtracting x from both the numerator and the denominator. And if you recall the video with the numeric fractions, I think we all agree that subtracting from the top and the bottom doesn't produce an equivalent fraction. So this is simplest form, no more common factors, and we're done. Okay, the fifth example here. So this is a fairly simple example, but I just wanted to be a little bit careful about what happens here, particularly with the denominator. It's not clear what the separate factors are there. There's a lot of multiplication happening there, and then it's also raised to a power. So I would be looking just to expand out that power first of all. So negative 2 squared is positive 4, and a squared is a squared. Okay, so now we can see the factors. We've got a times a on the top, or a squared on the top, and we've got 4 times a, or 4 times a squared on the bottom. So there's clearly a common factor of a squared. So if we divide the numerator by a squared and the denominator by a squared, we have just 1 left on the numerator, and 4 times 1, so 4 on the denominator. So this simplifies to 1/4. And our last example, so again, our first priority is factorising, making sure that we have numerator and denominator written as a multiplication of things. So the numerator is factorised. We've got 8 times y minus 3 times y minus 3. So that's okay as it is. We just need to look at the denominator. You might choose to write those squareds out if you find that hard to see. You don't need to, but I'll write it out here just so you can see what's happening. The denominator, we're looking for common factors. Yes, there's a common factor of 12, and that leaves us with y minus 3. And so now we've got a few common factors happening here. 8 twelfths, there's a common factor between 8 and 12 of 4. So if we divide numerator by 4 and denominator by 4, we also have a common factor of y minus 3. So we can divide numerator and denominator by y minus 3. So on the numerator, we're left with 2 times y minus 3, and on the denominator, we're left with 3 times 1, so just 3. We can write it in that way. That's also equivalent to 2/3 of y minus 3. Both are the same thing. Both are perfectly fine. So simplifying, one more, sorry, we do have two more. So here we have an interesting example because the numerator and denominator look very, very, very similar, but they're not quite. So there aren't any obvious common factors here because, there's only really one in common, or I guess -1. But in fact, the negative is what's key here because the numerator and denominator here are almost exactly the same except that the signs are switched around. The negatives are backwards. So if we think about, we can either work with the numerator or the denominator. Maybe I'll leave the numerator as it is. If I think about that denominator, that is the same as a minus b, except that it is -1 times a minus b. If I look at factorising -1 out of that, if you expand that back out, you're going to have -1 times a, which is -a, and -1 times -b, which is positive b, so b minus a. So sometimes just factoring out -1 can create those common factors if they're not quite there. So now, here we've got just 1 times a minus b over -1 times a minus b. So dividing top and bottom by a minus b, we've just got 1 divided by -1. Positive divided by negative is negative. 1 divided by 1 is just 1. So that is just -1. Similar example here. So we've got everything already factorised for us here. We don't need to do that ourselves. There's no numbers in common, but x plus 7 is common, so we can divide both the top and the bottom by x plus 7. And then I might just simplify this now. So I've got 1 times x minus 2 over 3 times 2 minus x. And again, we've got this same kind of problem. It's sort of almost the same, but not quite. And in fact, it's the negative. The numerator is the negative of the denominator, or the denominator is the negative of the numerator. So again, if we think about that denominator, and if we think about factoring -1 out of that bracket, so we're going to have -3 times x minus 2. Now we see that in fact we have got the same common factor of x minus 2 here, once we've taken that negative out. And so dividing both the top and the bottom by x minus 2 leaves us with 1 over -3, which is -1/3. You could also have factored the negative out of the numerator. That's perfectly fine as well. You could write that as -1 times 2 minus x over 3 times 2 minus x. Cancel out your 2 minus x's, leaving you with -1/3 again. So if you've got the same terms but they're just the wrong way around, think about taking out a negative and whether that might help you to create a common factor that you can then cancel down. Okay, so in summary, fractions can be simplified by dividing both the numerator and denominator by any common factors. So when we're dealing with algebraic fractions, we must first factorise the numerator and denominator in order to identify those common factors. And the fraction is in simplest form if the numerator and denominator do not have any further common factors. So the key thing in simplifying algebraic fractions is about factorising everything before you go cancelling anything down, in order to make sure that what you're actually doing is dividing top and bottom by the same thing rather than subtracting the same thing from top and bottom. So over to you. Exercise 1B in your BTG booklet is a collection of simplification of algebraic fractions, and we'll look at some slightly more complex examples in the next video and in the next exercise.